Okay, so as in the last video, we have discussed or we have calculated the molar mass. What was molar mass? Molar mass was basically the mass of 6.022 into 10 to the power 23 atoms or molecules of any element or compound, right? And 6.022 into 10 to the power 23 was the Avogadro number, which was calculated by Italian physicist Amedeo Avogadro. Alright, and we have just learned how to calculate the molar mass. When we were calculating the mass of only one atom of any element, that we were calculating in AMU, right? For example, we just took carbon atom, right? And we know that what is the mass of one atom of carbon, that is 12 AMU. However, I want the molar mass of carbon, so what I did, I just took that 12, instead of AMU I wrote its value, that is 1.67 into 10 to the power minus 24 gram. And then I want not the mass of only one atom, however I want mass of 6.022 into 10 to the power 23 particles or atoms, right? So I just multiplied that value, since at the end I got 12 gram, and that was basically the mass or the molar mass, or you can say atomic mass of carbon atom. So another name for the molar mass is atomic mass, right? So in today's video, now we are going to discuss, or we are just going to find the number of moles, right? So we are just going to find the number of mole, and we'll be beginning our lecture with a question, right? So we have a question. Question is find number of moles. Here I'll guys tell you about the formula as well, so this lecture is very important. Find number of moles of oxygen atoms present in 64 gram of oxygen. Alright, and I have initially told you what is mole. Mole is basically work as a bridge, and it gives us the connection between the mass of the substance and the number of particles present in the substance. Alright, either they'll gonna assign you the mass of the substance and they'll ask you to find the number of particles or the moles, or they'll gonna assign you the number of particles and the mole, and you will need to find the mass of that particular compound or atom or element, right? So here we have just got the mass of oxygen, right? This is the given mass, and now we need to find the moles of the oxygen atom present, right? So for this we have a formula, and that is equal to mole is equal to given mass per molar mass, and we know that what is molar mass. It is basically mass of 6.022 into 10 to the power 23 atoms, right? So now given mass will always be given in your question, right? That is basically your given mass. And molar mass, I have already made you guys understand how to find the molar mass. We have just found the molar mass of these all, right? And now you guys have a clear idea how we're gonna find the molar mass of any element or any compound, right? So now we need to find the number of moles. So number of mole is basically denoted by n. This is a representation of mole, right? Given mass, we have given mass, that is 64, upon what is the molar mass of oxygen. What is the molar mass? We know that the mass of one atom of oxygen is 16 AMU, but I want the mass of 6.022 into 10 to the power 23 atoms of oxygen. So 16 instead of AMU, 1.67 into 10 to the power minus 24 gram, into I want the mass of 6.022 into 10 to the power 23 atoms of oxygen. When I multiplied these all, I got at the end 16 gram. So 16 gram is basically the atomic mass, or you can say molecular mass. So I have written here 16. Now divide this. 16 ones are 16, 16 fours are 64. So number of mole which are present in the oxygen atom is what? These are 4, right? These are 4. So we have just found the number of mole by the very first formula we have read in today's video, and that is given mass per molar mass or given mass per atomic mass, right? You will have a given mass in the question that would be given. However, I have made you guys calculate the molar mass, and you need to divide your given mass by the molar mass. At the end you will gonna get your mole. In the question they can ask also the given mass. If the mass isn't given in the question, they'll gonna give you the moles. All right, if they ask you there are 4 moles of oxygen atom, find the mass given, right? So now we know that they have given us 4 moles. We need to find the given mass, right? That is basically not given in the question. We are just taking an example, right? We need to find the given mass, and we know that what is the molar mass of oxygen, that we have already found, right? That is 16 gram. 16 gram. Now let's just write that formula again. Mole is equal to what? Mole is equal to given mass gm upon mm, molar mass, right? Mole, number of mole is equal to 4. It is already given. So 4 is equal to given mass we need to find. Instead of gm I am writing x, right? And molar mass of oxygen is 16 gram. Here 16 is multiplying. When it will go there, it will be here it is dividing, and when it will go there, it will be multiplying. So x is equal to 16 fours are 64 gram. So now see, we have got 64 gram given mass, and that was already given in this question. We were supposed to find the moles, and we got the number of moles as 4. So in the question, if I do talk about this formula only, they can either give you number of moles, and they will gonna ask you for the given mass. Then what you will be doing, you will be applying this technique. Since you will be known about the molar mass, I have made you guys understand how to calculate the molar mass, and the moles would be given in your question. You will be supposed to find the given mass, right? So you will be applying the same formula. Mole is equal to given mass per molar mass. Instead of mole, you will write the given mole which is given in the question. Instead of gm you can write x, and molar mass that you already know, right? So that will be multiplied, and you will gonna get your given mass. However, if they have not given the moles, they have given the given mass. Yeah, now you need to find the moles, right? So number of mole is equal to given mass per molar mass. Given mass they have already given 64. Molar mass of oxygen we have already counted 16. So 16 ones are 16 fours are. So number of mole is equal to 4 moles, right? So either they can ask you to find the number of moles, or they can ask you to find the given mass. So you need to use this formula. Mole is equal to given mass per molar mass. Now let's do some more questions, right? So let me now write this here. Let me erase this a bit. Okay. So our next question, we're gonna practice a lot this question so that it should be more obvious to us, right? So question, find number of moles. We need to find the number of moles of atoms present in right? Now there will be a question. Wait, let me highlight this one. We need to find the number of moles. If they have asked us to find the number of moles, means they must have given the given mass in the question. That we will be using the given mass, and that we will be dividing by the molar mass of the particular element or the particular atom they will be asked for, right? So the first one part is what? we need to find the number of moles present in the 28 gram of nitrogen atom. Now I hope you all can do this by yourself as well. Second, we have 32 gram of sulfur atom, right? Sulfur atom. Last but not the least, we have is 14 gram of hydrogen atom, right? Now we need to find the number of moles, and I have already told you the formula for it, right? Wait, let me just highlight this. Since I have already told you, if they have asked to find the number of moles, they must have given the given mass in the question. So as you can see, they have already given the mass. Now the formula is mole is equal to given mass per molar mass, right? Given mass is what? The given mass is 28, right? 28. And the molar mass of nitrogen we have already counted, right? It's here. We have already counted 14 into 1.67 into 10 to the power 24 instead of AMU into, we are finding the molar mass, and that would be the mass of 6.022 into 10 to the power 23 particles. And at the end we got 14 gram. So divided by 14 gram. 14 ones are 14 twos are, and we got 2 moles, right? So how many moles would be present in the 28 gram of nitrogen? There would be 2 moles present in the 28 gram of nitrogen atom. I hope this is now very clear to you guys. Okay, now let's solve the second one, and that is very easy as well. Apply the same formula. Mole is equal to given mass upon molar mass. Given mass we have is 32 gram. So 32 gram upon the molar mass of sulfur we have already counted, I guess. It's here, right? And we have gotten 32 gram. So divided by 32 gram. 32 upon 32 we get 1 mole. So how many moles are present in the 32 gram of sulfur atom? There is only 1 mole present in the 32 gram of sulfur atom, right? The last but not the least, how many moles are present in the 14 gram of hydrogen atom? So mole is equal to given mass per molar mass. Given mass they have already given in the question, and that is 14 gram, right? 14 gram upon the molar mass of hydrogen is what? We know that the mass of one hydrogen atom is 1 AMU. Instead of AMU, 1.67 into 10 to the power minus 24 gram, and we are finding for 6.022 22 into 10 to the power 23 particles. So when we will gonna solve this, we will have 1 gram. So 1 gram is the mass of 6.022 into 10 to the power 23 atoms of hydrogen, right? So just divide 14 by 1 gram. What we will gonna get is 14 moles, right? So how many moles are present in the 14 gram of hydrogen? There are 14 moles present in the 14 gram of hydrogen. How many moles are present in the 14 gram of hydrogen? There are 14 moles present in the 14 gram of hydrogen atom. I hope today's lecture is very clear to you now, as we have discussed the first formula, and that is mole is equal to given mass per molar mass, right? And we have just done, or we have calculated the number of moles which are present in the particular elements, atoms, right? So in the next video we will be discussing more about it, and maybe we will be going with another formula for calculating the moles as well. This was all for today.